Alright, in this video we're going to take a look at one last possibility that you need to be aware of, and that's one in which you have what are called irreducible quadratic factors. So we're going to take this and we're going to factor it, and we're going to factor it using factoring by grouping. So that can factor into, I'm going to take out an x squared, so that denominator can be rewritten as x squared plus 1 times x plus 2. And now the idea here is we're going to do the same thing we've normally done, except that there's a linear factor in the denominator, the x plus 2, but then there's a quadratic that can't be factored anymore. It's an irreducible quadratic, hence the name. So we can break this up into a over x plus 2, but then we have to write the numerator as bx plus c, and that allows for the possibility that there's a linear term in the numerator, because the bottom is a quadratic. So there's always a possibility that that will be 1 degree less than the numerator, or denominator rather. But now we do the same thing we've always done. We'll get a common denominator. And so now we see that we get x squared minus x plus 3 equal to a times x squared plus 1 plus bx plus c times x plus 2. And now I can plug in some convenient values. So when x equals negative 2, the left-hand side becomes 9, and the right-hand side becomes negative 2 squared plus 1 is 5, so it's 5a. And that bx plus c times x plus 2 cancels, so now we know that a is equal to 9/5. So I need to clean that up there. Alright, and so now we'll try another value. And actually at this point we really don't have, there's really not much we can do, because we've already there's nothing we can do to make that a term go away, to vanish. So we've got a couple options. One is to just multiply out the right hand side, and if you do that, you end up getting that this becomes ax squared plus a plus, now if you multiply that other term out, you get bx squared plus c plus 2bx plus 2c. So now what we want to do is we want to group the quadratic terms. So when we do that, we get a plus b x squared. We want to group the linear terms, which are already grouped, c plus 2bx, and then a plus c, or a plus 2c, will give me my constant term. So now I can match these up. So a plus b has to be a 1, c plus 2b has to be negative 1, and 3 has to be a plus 2c. Now we already know what a is, so that'll help us find b, because a was 9/5. So 9/5 plus b equals 1. That must mean that b is negative 4/5. And then that means we can find c just using the bottom equation. We already know a is 9/5, so 9/5 plus 2c equals 3. That's 15/5 is what 3 is, minus 9/5, you get 6/5, divided by 2 is 3/5. So c is 3/5. Alright, so now what we can do is rewrite our integral. Our integral is now 9/5 divided by x plus 2 plus our bx plus c. Our b was -4/5 x plus c, which was 3/5, divided by x squared plus 1. And the left integral is actually easy. We know that that can be written as, so this is just 9/5 natural log of absolute value of x plus 2. So that integral is done. This one on the right here is not done, and we've got to do a little bit of work here, because we need to write that, as, well, I'm going to break it up. I'm going to write it as -4/5 x. Well, I'm going to write it like this. If you multiply the top and the bottom by 5, you end up just getting this. And then this becomes 3/5, or 3/5 x squared plus 1. So now what we can do is, we've got these two integrals to deal with. I think the one on the right, this guy here, is easy because it's just 3/5 times the antiderivative of 1 over x squared plus 1, which is tan inverse of x. And this one in here, I think we can do with a substitution. So here I'm going to let u be 5x squared plus 5, which is this denominator. And therefore du is going to be 10x dx. Now we've got a -4x there instead of a 10x. So what we can do is we can multiply by, or we can call du over 10 the same as x dx. So then I'll just put in a dx there. So I'll put in du over 10 for my x dx, and then that 4 will interact with the with that substitution. So that ends up being -4 x dx was du over 10. Put the 10th there, and the du, and the denominator was our u. So again, we were done with these guys, and we're just working on this one here. So this is -4/10 antiderivative of 1 over u du, which is -4/10 natural log of the absolute value of u, which is -4/10 natural log, and the absolute value of u is the absolute value of 5x squared plus 5. Alright, and so putting that all together, we put all the pieces together, our final answer is 9/5 natural log of the absolute value of x plus 2 plus -4/10 natural log of absolute value of 5x squared plus 5 plus 3/5 tan inverse of x plus c. So that one was kind of a nightmare, but we're there. And the big idea was that irreducible quadratic factor at the bottom up here. That's the real take home from this is this guy right here. And then after that, if it turns into a nightmare, you just got to kind of deal with it. This quick video, I just want to show you to be careful not to try to overuse partial fraction decomposition. And in particular, if you look at the denominator here, it doesn't even factor, so you can't use partial fractions. So that might seem like a dead end, but you can use u substitution if you let u be that whole bottom, because then du would just be 2x plus 6, which is the same as 2 times x plus 3, and what do you know? Du over 2 is equal to x plus 3 dx, and now that can be substituted in here, and we'll end up getting the integral du over 2 over u, which we know is 1/2 ln the absolute value of u plus c, which is 1/2 ln absolute value of x squared plus 6x plus 1 plus c. Alright, so sometimes even though it looks like a partial fraction decomposition problem, it really could just be a straightforward u substitution problem. So I would probably try that first because it's less work than doing partial fractions. So just be on the lookout for problems that are really just substitution problems.